Hi math friends, we're going to look at our sequences and function or not. And before we get started, remember, you can't spell function without fun. Alright, so let's check out some sequences here. So determine the next term, 4, 11, 18, 25. Sometimes we need to think about these a little. The pattern here is plus 7 each time you're adding 7. So the next term, that's what we're looking for, would be 32. Alright, our next sequence, 3, 6, 9, 12. So in this sequence, we add 3 each time. So our next term would be 15. Our next one was actually in our notes that we did in class too. But let's check this out. So our first term is 1, then 3, then 6, then if we count these, 10. So this one has a slightly different pattern. So if we're looking at adding, it's plus 2, but then it's going plus 3, and then we got a plus 4. So if we continue that pattern, we're adding 5 more, and that's adding a bottom row of those circles in there. So if we want to draw that out too, so we're going to recreate the pattern that we just had, and we're going to see that this is the absolute best drawing that we can make on here as well. A little bit tricky to make with the touchpad. And then we make one more bottom row. And when we do that, we see that we're actually adding 5. So our last term has 15. Now the important thing here is the picture too, right? So if you want to draw it and write the number, that would be great. Alright, determine if this represents a function or not. So when we have this mapping, that's what we call this for number 4, we want to make sure that each input has one output. So like this negative 19, this goes to 10. This negative 14, this goes to negative 9, negative 11. Yeah, it only goes to one thing. But when we get to this negative 9 has two outputs. It's going to negative 16 and it's going to positive 9. So it has two different outputs. So for this one, we're going to say not a function. And we're going to make sure that we explain exactly for that reason. We want to make sure that we write this well, and we want to be succinct in this. We don't want to write too much. I'm going to say the input of negative 9 has two different outputs. Now, if this would have been negative 16 and then it gave it negative 16, that would have been okay. But the two different outputs, yeah, that doesn't work. Number 5. So this is where we look at the vertical line test because we have a graph for this. So if you have a vertical line, and when you do this on paper, like even like your pencil would work, pass it through the graph. It doesn't, this U shape is what we're looking at. It never touches this more than once at the same time while you're moving this vertical line. So this one is a function. And because we use the vertical line test, we're going to say it passes the vertical line test. All right, again, determine if they're functions, so input, output. Look at your input, your x values. Let's see, do they repeat? And if they do repeat, do they have different outputs? So 1, negative 1, 2, and 8. So none of those inputs repeat. So yeah, that is a function. So then y, we're going to say each input has exactly one output. Same idea for the table. Let's look at our x values. Let's see, do any of these repeat? It looks like this negative 3 comes up twice. So then let's check. Does it have a different output? Negative 3 yields 7, and negative 3 also yields 14. So yeah, not a function. We got two different outputs for negative 3. So then y, we're going to say the input of negative 3 has two different outputs. And we are going to keep our explanation short and succinct like that. All right, consider the graph below for this problem. So classify the circle that apply. So this is continuous, yes. Remember, continuous means that it's following this line. Discrete would have been like just a couple dots. Like if it was only like dots like this instead of being connected by a line, that would be discrete. Linear. So linear would be if it was a straight line. So this one is nonlinear because there's a lot of different parts of it. It's not just one single straight line. Just increasing, just decreasing. So just increasing would be like maybe like that. That would work too, but we see parts going down as we go left to right. So we have increasing and decreasing here. So these are the only three things that we would classify for this graph. All right, now it says consider this graph, create a scenario. So my suggestion when you do a scenario is to always section off each part of this that's different. So this first slope here, this zero slope, we're going to call A, and then we're going to move around here, B, and then even though this is another negative slope here, it's different than B. So we're going to call this C, and then D, the zero slope at the bottom, and then finally E. All right. And we can think about what we did in class too. And my suggestion for you was always write a sentence or two for each thing. And you can even label it. Sometimes labeling that helps us to keep things in order. So for part A, we're going to say we looked at, and we have to decide what this is, right? There's no story given to us. So we looked at the water level of a pool. And then for part B, you can say we started to drain the pool. So draining the pool meaning the water is leaving. That's why we have a negative slope. Part C, we drained it faster until there was no water left. You see that because for part D, that reaches all the way to the bottom. So part D, so there's no water in the pool, so we cleaned the empty pool. And then we got one thing left, part E. We're going to say we refilled the pool so we could use it. All right, and remember, we can keep things short and succinct like that, and if we section them off and even write the letters there, that's really going to help us keep things in order, keep all of our thinking there so that we can show, how excellent we understand this, all right? Good luck, math friends, and we'll see you later.